Yeah, we have done few fill in the blanks from here. Few are left. Let's continue and let's move ahead. As I can see here, an arc is a semicircle when its end are end of diameter. So whenever we are taking the end of diameter, the arc will be a semicircle, because diameter means the longest chord, a chord passing through the center of the circle. And if we will be taking the arc like this, it will be definitely a semicircle. Let's do the next fill in the blanks, which says segment of a circle is the reason. I believe you all can see my screen. So segment of a circle is the reason between an arc and dash of the circle. If you understand what exactly is the segment of the circle, then in the beginning of this chapter only you must have done the concept of segment and circle. We know whenever we are having a circle, then when we will be drawing a chord, then this is called the segment of the circle. And if we are drawing two segments in such a way, one is a smaller, one is bigger, then we can say this one is the major segment and this one is the minor segment. So segment is the reason between arc and what? Between arc means between this sky part, arc, and the chord of the circle. As we can see, we have to draw a chord to get the segment. So here it will be chord of the circle. Segment of a circle is a reason between an arc and the chord of a circle. Now the next one is a circle divides the plane on which it lies in dash parts. Whenever we are talking about the circle, the very basic definition of circle says whenever we are having a circle, this is called the exterior part of the circle. Outside part, everything outside of the circle is called exterior part of the circle. This is called the interior part of the circle, and this is called the point on the circle. On the circle. So a circle divide a plane. This plane paper, it is dividing in three parts: interior part, exterior part, and on the circle also. So here we'll be writing three parts. Okay, now few true false questions are there. Let's go through it. Let's do it quickly, and then we'll be starting few theorems. So the first one says line segment joining the center to any point on the circle is a radius of the circle. Is it so? Is it true or not? So as we can see, the statement says line segment joining the center to any point on the circle. Obviously, whenever we are joining the center of the circle, that means the fixed point on the circle, to any point on the circle, the center whenever you will join with any point on the circle. This is a radius, this is a radius, this is a radius, this is a radius. This all are just radius. OA is a radius, OB is a radius, OC is a radius, OP is a radius. So yes, line segment joining the center to any point on the circle. This word, this uh, phrase is very important, on the circle. So on the circle only, if we are taking any point and joining it with the center, then and only then we will be getting the radius. So yes, it's true. Next statement says a circle has only finite number of equal chords. A circle have only finite number of equal chords. Whenever we are talking about a circle, we can draw as many chord as possible. Like infinitely many chord we can draw over there. And yes, equal chord also we will be able to draw. And infinitely many equal chord we will be able to draw over there. It's not saying two equal chord, it's saying how many equal like chords we can draw. So a lot of equal chord we can draw. Finite, it's not necessary it will be finite. Infinite number of chords we will be able to draw. So this is false. Now the next statement says, anyone having doubt anything till here? Is it clear so far to everyone? Is it clear so far?
Yes, yes.
If a circle is divided into three equal arcs, each is a major arc. When we are talking about major arc and minor arc, major segment, major sector, minor sector, when one is bigger, another is smaller. Here, if we are dividing it in three, whenever we are talking about equal thing, nothing is major, minor. Major means the word itself is saying about itself. Major means larger, minor means smaller. And if you are having 20 chocolate, I am having 20 chocolate only, and one more student is having 20 chocolate, all are having same, then no one is having larger, no one is having smaller, all are on the same page. So major arc, it's false. This statement is false. If all the three arcs are same, then it's not major, it's not minor. Major, minor, we only talk about this word when we are having one larger, one smaller. Okay, let's continue. A chord of a circle which is twice as long as its radius is a diameter of the circle. So a chord of a circle which is twice as long as its radius is the diameter. Obviously, diameter is 2 times the radius. So twice as long as its radius. Twice the radius. Is it diameter? Yes, it's a diameter. Okay. So this is true. Now the next one says sector is the region between the chord and the corresponding arc. Sector is the region between chord and corresponding arc. Is it so? This is called sector, a chord and the corresponding arc. This is called the sector of the circle. Is it so? Is it the sector of the circle? Yes or no?
Yes,
Yes. Then what is this one? What is this one? This is called the segment of the circle. When we are drawing a chord and the arc, the region bounded by the chord and the arc is called the segment, not the sector. And the region bounded by the radius of the circle. Let me share it again. Region bounded between the radius, this radius, and the, can you see my screen?
no, ma'am.
Just a moment, let me share it. So region bounded, I believe now you can see, right? So region bounded between the radius, this radius and this sky arc. This is called the sector of the circle. So please don't get confused between the sector and the segment. Segment means we are just drawing a chord. We will be drawing a chord and this is called segment. Whereas this is called the sector. Here also we will be talking about the minor sector and the major sector. So sector, we get the sector of the circle when we draw two radius and the arc. So this is the area bounded by radius and the arc, whereas segment is the region bounded between the chord and the arc. So this is the difference between sector and segment. You can see both the figure number 1 and figure number 2. Figure number 1, I have plotted sector of the circle. Figure number 2, I have drawn the segment of the circle. What exactly the statement says? The statement says that the sector is the region between chord and the corresponding arc. So sector is not the region between chord. Chord means whenever you will take 2 points on the circle and you will join them, that time you will be getting a chord of the circle. So sector definitely, it's not the region bounded between chord and arc. It is the region bounded between radius and the arc. So this is false. Got it?
Yes, ma'am.
Now the next one is a circle is a plane figure. Yes, a circle is a plane figure. A circle is a two-dimensional figure. A circle is a flat figure. A circle is a plane figure. Whatever name you want to give it, give it. It's a 2D shape. It's not three-dimensional shape. So yes, a circle is a plane figure. It's true. Now the next theorem which we want to do over here is, let me write the theorem first and then we will be proving it. 2-3 theorems already you have done in the first class, right? Yes or no?
Yes, ma'am.
We will be proving equal chords of a circle are of a circle, or we can say congruent circle also. Congruent circle means two circle having the same radius. Both the circle are exactly same. That means both the circle is having same radius. So those are called congruent circles. Our equidistance from the center. This theorem we are going to prove over here. One more theorem we'll be taking over here. Let me write that also. We'll be working on this these theorems over here. Just a moment. The one more theorem is there. I believe the. Let me check how many more are there. Okay, let's do it at first. After that, I am taking the next one. So here, what exactly it says? Equal chord of a circle. If we are having a circle, if we are having a circle like this, and we are having equal chords. So let's say we are having one of the chord, this one, and one chord over here. The name of the this chord is AB and this chord is PQ. However, if it doesn't look same length in my figure, don't worry, my circle is not the proper circle. It's not, it's just the rough sketch of a circle. When you will be drawing it, you can use the scale to draw equal two chord by just with the, like, by taking equal chord. Okay, AB and PQ has to be same. Are equidistant from the center. Here is a center O. We have to show that equal, if AB, it is given that AB is equals to PQ. How I am saying it's given? Because the first, like first two word only says equal chord. So two chord we have drawn, AB and PQ. We are taking both of them as a equal chord. Are equidistant from the center. So we have to prove that from the center, this chord, that is, let's say OM, and this chord, let's say ON, both are equidistant. OM length, OM distance, and ON distance are same. That's what we have to prove over here. Now you must be thinking, whenever I'm talking about the distance, why I'm taking distance this way. For that, let me explain you something. Suppose we are having a point and we are having a straight line. Okay, from this line L, you can take this distance, you can take this distance, you can take this distance, you can take this distance. What I am saying, just listen to me carefully. I am saying distance of a point P from the line L. Distance of a point P from the line L. You can take any distance. You can take this, the distance PA, you can take distance PB, you can take distance PC, you can take distance P, let's say E, you can take this distance PF, you can take distance, let's say PS, you can take distance PN. How you will be particular about, it is asking about which distance exactly, because here just by the visual expression, like visual figure, we can see all the distance are different, like all are not looking same. And even if you will do it with a ruler, scale and pencil on the paper, you will be seeing that distances are different. So it's talking about which distance, distance of a point from a line is which distance. So when you will be dropping a perpendicular from P, a perpendicular distance when you will be dropping, let me drop it properly, a perpendicular like this, what you will find that among all the distance, this perpendicular distance is the minimum distance. And that's what whenever in mathematics it says that take a point and that point distance from the line, that means you are going to take the minimum distance, that is the perpendicular distance. So that's why from the like in the previous class also I said to you, whenever it's talking about the distance, you have to take the perpendicular distance. Why only perpendicular distance? Because you can see here all the distances are different and the minimum distance is the perpendicular one. So why not to take the minimum distance only? That is the perpendicular distance. So whenever it says distance of point P from line L, we will be taking perpendicular distance of P from L. That means here I can say, let's say it is Pn. Distance Pn we have to find. Okay. So whenever it is talking about the distance of a point from a line, that means perpendicular distance. Let's get back to our question. So equal chord of a circle are equidistant from the center. Equidistant means, again, center is a point and chord is a line. So equidistant means we have to check whether the perpendicular distances are same or not. We have to check whether this OM, which is perpendicular, we are dropping, and ON, which is also perpendicular, we are dropping on the chord, because distance means perpendicular distance. This OM and OR are same. OM and ON, both the length are same or not. Both are perpendicular distance. So it is also given that OM is perpendicular to AB, because whenever we are talking about distance, it's a perpendicular distance. ON is perpendicular to PQ. That we know already. We have to show that OM is equals to ON. Okay. Now to prove OM is equals to ON, let's join this center with this point A. And let's join this center with this point B. So now you can see two triangles over here. I am talking about triangle ONQ and triangle OMV. Can you see both the triangle? I am talking about the sky triangle and I am talking about the black triangle. Here what we know that is 90 degree, M is 90 degree, N is 90 degree. What else we know? Anyone?
O is
Any?
common.
What else we know here? We know here that angle OMB, angle ONQ is equals to angle OMB. Why? Because both are 90 degree. We also know that OB is equals to OQ. Why? Anyone? Why OB and OQ are same? Why it's same in both the triangle OB and OQ? Because it's the radius of the circle. You OB, if you will look at it carefully, it's just a joining a line from the center to any point on the circle, and it is called the radius of the circle. This is also called the radius of the circle. So both are radius only. Obviously, both has to be same. So we will be saying here radius of the circle. Now we know that chord AB is equals to chord PQ. Then half of the chord AB will be equals to half of the chord PQ. Why we are doing half half? Let me show you. It is already given that chord AB is equals to chord PQ. That was already given part I have just copy pasted. Then half of chord AB will be equals to half of chord PQ. Obviously, if total is same, then half of that and half of this has to be same. What's the benefit of taking half of that and half of this? I want to say there was a theorem where perpendicular dropped from the center on the chord bisect the chord. Let me write it. This theorem you have done in the in the first class, I believe. Have you done? Let me write the theorem. Perpendicular dropped from the center on the chord bisects the chord. Do you know this theorem? Everyone, please let me know whether you know this theorem or not.
Yes, ma'am.
So you already know this theorem. That's why I'm taking half of the first chord and half of the second chord, because I know that since we have dropped the perpendicular, our chord is getting bisected. It is getting cutted into half part. So from here only I'll be writing that half of AB, that means BM, is equals to half of PQ, that means QN. So from here I want to write BM is equals to QN. Okay. Now let's see what exactly are same. So I am saying let's focus on the sky triangle and the black triangle. We are saying that BM is equals to, let me write it over here. We are saying that BM is equals to QN, because both are just cutting the chord in half part. So if total are same, half has to be same. Now we are saying OQ and OB is the radius. We are also saying that angle M is 90 degree, angle N over here is 90 degree. So now we can say these two triangles are congruent. By which congruency criteria? By which congruency criteria? For that you have to get back to your triangle and you have to check it in your triangle which criteria is getting fulfilled. So here we are using the angle. I would mention that's a right angle. Here we are using right angle. Then BM, this side we are using, and this side also we are using, which is a hypotenuse. So can you tell me which criteria is getting fulfilled? Which criteria of congruency is getting fulfilled? Do you know the concept of congruency? Have you done congruency? So here we can see right angle, hypotenuse and side. RHS congruency criteria is getting fulfilled. We can say that both the triangle, that is sky triangle and this black triangle, are congruent with each other by RHS congruency rule. So let's write it, triangle O and Q. If you are not understanding this part, that means you don't you have not done the chapter triangles. If you have done the chapter triangle, then this will be pretty much clear to you. So at first you need to have the knowledge about triangle chapter. That's why we say that mathematics is just, it's connected, each and every concept is connected with each other. If you don't know the previous one, you will not be able to do this one. And it is not just limited to this class only, it is just applicable throughout, from the very beginning. Whatever you have learned, the addition, subtraction, numbers, natural number, prime number, even number, odd number, everything from the very beginning, whatever you have learned, here and there we will be using that. So if you are missing on something, that is not the problem. You just need to get back to that portion and you just need to revise it. So here we are having triangle ONQ is triangle ONQ is congruent with triangle OMB. Let me check the name I have written properly or not. So BMQN. Yeah, BMQN. AB is AB not. OB is equals to OQ. OB, OQ. Angle and yeah. So the name also I have written it properly over here. In congruency, whenever we are writing both the triangles are congruent, we must write the name properly, because from here only we will be able to say by CPCT, by corresponding part of congruent triangle, our what we wanted to prove, OM is equals to ON. So by CPCT we can say ON is equals to OM. You can see both are sitting at the same places also. That must be the case. So ON is equals to OM. How? By CPCT, which means corresponding parts of congruent triangle are same. Okay. So this is how we have proved it. Let's prove the converse of this same theorem. So the converse of this theorem says, here what we have proved, let's get back to the theorem. We have proved not only the proving part you need to keep in mind, you also need to keep in mind this theorem which says that whenever chord are same length, then the distance from the center will also be same. If your one of the chord is 6 centimeter in a circle, if your one of the chord is 6 centimeter, another is also 6 centimeter, then both the chord will be sitting at a same distance from the center. Okay, this is what we have proved over here. Apart from keeping in mind the process of the proof, you also need to apply this theorem here and there. So let's see this theorem like just for a while, and then we'll be moving for the next theorem. So the theorem which we have proved says that if your this chord and this chord, if this is 7 centimeter, this is also 7 centimeter, then from the center this distance is, if this distance is 3 centimeter, then this distance will also be 3 centimeter. Both will be sitting at a same distance from the center. Similarly, if you are having a circle, if this chord and this chord, let's say this is 5 centimeter, this is 5 centimeter, then from the center, this distance and this distance has to be same. If this is x, this has to be x. That's what the theorem says, which we have proved just now. That if both the chord length is same, then both the chords distance from the center will be same, and we will be using it while solving a lot of questions. Okay, this theorem again you will get back to this theorem when you will go in class 10. That time you will be applying this concept in the problem directly. You don't need to prove it over there. There will be few more circles theorem, and that time you will be using this theorem a lot of time while solving the problems. So is it clear what exactly this theorem says? That if we are having a circle, and if there is a chord like this, there is a chord like this, and if this chord is 5 centimeter, this chord is also 5 centimeter, then from the center perpendicular distance this one and perpendicular distance this one, both will be same. That means if this is y centimeter, this will also be y centimeter. If ON is y centimeter, then OM will also be y centimeter when the two chords are of same length. Okay, let's prove the converse of this theorem. Chords equidistance from the center of a circle are equal in length. This says that when the chord are equidistant from the center, if there is a chord, okay, and if the distance is 2 centimeter over here, and if there is another chord, and here also from the center, the distance, perpendicular distance is 2 centimeter only, then both the chord, that is chord ST and chord MN, both will be of same length. It is just the converse of the previous theorem. Here also we are going to apply the same logic. Here also we will be taking the triangle and we will be proving that two triangles are congruent, and then easily we will be able to say by CPCT both the chord will be of same length. So let me plot the diagram at first. So let's say we are having this circle. Okay, here we are having one chord and here we are having another chord. This is the center O. Theorem says chord equidistance from the center. So this distance and this distance, both are same. Okay, O, M, O, N. Given that OM is equals to ON. Equidistance means the perpendicular distance. Again, I am saying that whenever from a point on a line, whenever you are talking about a distance, you have to take a perpendicular distance only. Now we have to prove to ST is equals to MN. Here also you will be plotting a sky triangle and a black triangle. Whatever triangle you want to name it, please name it according to your wish. So I'm talking about this is sky triangle and this black triangle. Okay, we will be showing that both the triangles are congruent with each other. Again, just like the previous way, 90 degrees there. You can see this is radius, this is radius, and you can also see that side ON, OM are given as the same. So obviously both the triangle will be congruent. So triangle NOT will be congruent with triangle MON. Okay. Now from here we will be able to say that NT will be equals to MN. How? By CPCT. And once these two are same, 2 times of NT must be equals to 2 times of MN. That means ST will be equals to, okay, again and again I have given MN. Let me do the correction. Let's say this is QN. So ST is equals to QN. We have proved that both the chord are of same length. Again, here also we are using the same theorem, the previous theorem, that if this much is same, if half is same, then total will be same. How we know it is half half? Because we have dropped the perpendicular and it will bisect the chord. So if NT and MN, half part of one of the chord and half part of another chord are same, then full length of this chord will be equals to full length of that chord. That's how we can prove the converse of this theorem. That is, when the distances are same, the chord will be same. Previously we have done, when the chords are same, the distances will be same. Is it clear to everyone?
Yes, please.